Okay, so now we will show the functionality of the tip calibration and why this is really very critical when you're dealing with different tips. So let's say now we have our well-calibrated TCP and we have a well-defined sketch plane. And if we run this program, now we are going to be able to come in here and very closely follow uh, that blue square in order to dispense. But what would happen now if we were to take this tip and choose a different and put in a different tip? So let's say now we put in that tip and we run that same program. If we run that same program now, we are way higher on on that paper. We're way off, and the reason we're way off is because this tip is much shorter than this other one, right? So how do we correct that? So we could go in and redefine that TCP and sort of redo all that process, or we can turn on this function here, which is going to be tip calibration. So we'll basically just move to an approach point above our calibration plane. We will calibrate the TCP and then we will set it to do it with the set calibrated TCP. And if we do, so that is essentially, we're able to do that inside of the program node. That is equivalent to us coming in here with the tip cal and saying calibrate TCP. So this assumes that you have set up all of this and that you have measured your offsets. So we can do it here in the installation or we can do it programmatically within our program. So if we do it programmatically within our program, we will have our tip calibration and then our sketch path. And so now we will come down, we will detect our different height. So now we will measure our offset here, we will measure our offset on the other edge, and now we will go and we will very accurately again dispense following the path of the blue square so that it matches perfectly the height. And that is essentially the whole role of the tip calibration.